So we're going to look at parabolic questions in context, and this is very much excellent at year 11 and even in fact into year 12. While there often, when you're looking at questions, seems to be a range of questions, in fact there's only a couple of techniques that you need to know, albeit that they are quite hard. So first up, we write the general form for the parabola based on its x-intercepts with an unknown multiplier at the start. So the examples of those general forms are these. On the two intercepts, on an intercept of 0 going out to a point, turning at 0 or turning at a point. Now almost all of them are like this, with rare exceptions. So we take a point on a parabola other than the intercept, and that's normally the turning point, which is halfway between the intercepts, or is the y-intercept. So it's one of those 2 points. And we substitute that value into the general form of the parabola and solve to find the multiplier. At this point, you do have to have very good algebra because you need to be able to solve the problem. So let's take a very simple case. This parabola turns at 0, 0. And so it can be written in the form y equals x squared with an unknown multiplier here. And then using a known point, we can work out that unknown multiplier using w and h at this point. So let's put it going through at x equals 2, y equals 8. And this is our general form for such a graph. So what we have here is that y equals 8 when x equals 2, and so we can substitute those numbers into our equation. 8 is k times 2 squared, very quick multiplication, and we discover that k is 2. So this graph's equation is y equals 2x squared. So that was the process. We wrote the general form, we substitute in a known point, we solve for k, and then we write the formula at the end of that. So that's a very easy case because we're just substituting in a very simple point. Let's look at another relatively simple case. So the parabola turns at some width w, and so it's of the form some multiplier, which we're going to work out, x minus w squared. And we need to know a point. So in this case, we're going to use the intercept. So let's find out what it is when it turns at 10 and the intercept is 5. So here's our general form, and we know our w is 10, so that's that, and that gives us the general form of a parabola that turns at x equals 10. But when x equals 0, y equals 5, so we can substitute those values into the equation. Y equals 5 when x equals 0. 0 minus 10 is minus 10, minus 10 squared is 100, so 5 equals k times 100. We divide the 100 across and we get that the k is 0.05. So this is the equation of this parabola using our now found multiplier. You can put it in fraction form if you wish. Right, another example. In a case like this, we're going to write the equation from the two intercepts and then use the other point, the turning point, to determine the formula. So that's the general form, some multiplier we don't know yet, minus w plus w, these 2 points, and then we're going to use the h, height of the y-intercept. There's going to be negative in this case because it's an upside down parabola, but what you'll find is that that comes out in the working. So let's put it in. Let's say it goes to minus 4 and 4, and its height is 8. Here's our general form. We know W and W, so we put them in. So now that's the form for any parabola that has intercepts at -4 and 4. But we know y is 8 when x is 0, so we substitute that into our formula. Y is 8, x is 0, x is 0. So this bracket's -4, this is +4, makes that -16. We divide it to the other side, and our k is -1/2. So this is our parabola, -0.5, x minus 4, x plus 4. And basically, that's just what we do every time. The most normal case is a parabola which heads through 0, 0, and then has a turning point along the way, and then intersects back at some other point. So this is the general form of such a parabola. And in this case, we just have to know that halfway along is our turning point because of symmetry. So half the way to W is where it's going to turn. Easier if we just put in values and use the numbers. Again, k is going to be negative, but that comes out in the working. So let's say our parabola is 8 wide and 6 high. Here's the general form of that type of parabola from the two intercepts. We know this one is 8, this one is 0, and we put in our point 4, which is halfway across to 8, 4 across, 6 up, which is this point here. So y is 6 when x is 4. We substitute that in. That gives us k is 6 over -16. That's the sort of result you'll often get. It's not always going to be a nice whole round number. Putting the negative to the top makes it -6 over 16. So our parabola is -0.375, 6 over 16, x minus 8. A lot of students will prefer to leave it actually in the fraction form, that's fine. So, to recap, we have 4 standard cases, but what we do each time is exactly the same thing. We write the standard form for one of these, we put a multiplier in front, we take a known point, which is the turning point in the first case, the turning point in the second case, a point out on the graph in the third case, which is the least common, or the intercept in the fourth case. We put that into the formula and then we solve for k, and then we have our formula.